If you click this video away, please tell me what the reason for it was, so that I can improve. Otherwise, hi and welcome. I am trying to learn biochemistry today, acid-base balance, the concept of pH. And after we've done that, we're going to do extensor carpi ulnaris strength training. So we're going to train this part of the arm. If you participate in the extensor carpi ulnaris strength training, then it's at your own risk. Acid-base balance, the concept of pH. To ensure homeostasis, intracellular and extracellular fluids must contain almost balanced quantities of acids and bases. Okay, the human body should stay stable as it is at 37 degrees temperature with a water content of whatever, 75% or whatever it also is. And it is important for the human body that the intracellular and extracellular fluids, I still don't really know what it is, but something at the cells in the human body, inside of them and around them, has to have a balance of acids and bases. So there are two stuffs in the human body, and it should not be too much acid. It should be not too acidous in the human body. And the other thing, I don't know what bases now are. The more hydrogen ions dissolved in a solution, the more acidic the solution. Conversely, the more hydroxide ions, the more basic alkaline the solution. Okay, I don't really get what these two things are, but one of them is acid. These are H+, and the more of these acids, hydrogen items are in them, the more sour it is, the more acidous, and the more base alkaline are in them, the less. The chemical reactions that take place in the body are very sensitive to even small changes in the acidity. Acidity or alkalinity of the body fluids in which they occur. Okay, that means for the human body is it important that it stays very exactly. It's not about having a 10% more or less, a little bit more acid, but it has to be very exactly at the same place. Any departure from the narrow limits of normal H+, so acidity, the hydrogen amount, or the OH minus, the hydroxide ions, the alkalinity amount, concentrations greatly disrupts body functions. So it has to be very precise. So we have it. In the human body there are acids and bases, they are inside of the cells, around the cells, wherever, everywhere. And they have to be precise in a mixture of acids to alkaline, these two things. If there are too many acids, it's too sour and the cells die or whatever. If it's too many alkaline, they can't properly function. And it has to be very, very balanced, the amount of acid and alkaline. A solution's acidity or alkalinity is expressed on the pH scale, which runs from 0 to 40. This scale is based on the concentration of H+ in moles per liter. A pH of 7 means that a solution contains 1/10 millionth of a mole of hydrogen ions per liter. Okay, before we go to the numbers, okay, there is a scale. It says 0 to 14. If someone has 0, then they have no acid in them. If someone has 14, they are completely acid. And a 7 means something on that scale. So there's first the scale, pH scale. It means something. What does pH mean? We weren't told it. Okay, pH, there's a scale, 1 to 14. If something is 0, it has one thing, and the 14 is very strong of something, and 7 would be somewhere in the middle probably, but I don't know, it's no scale. And now, it is measured in moles per liter. A pH of 7 means that a solution contains 1/10 millionth of a mole of hydrogen per liter. The 7, that is, we're having 7 digits to the side, it's 1 millionth, a million has 6 zeros, that has something to do with 7. The numeric 0.00001 is written as 1 times 10 to the minus 7 or something like that in scientific notation, which indicates that the number is 1 with the decimal point moved 7 places to the left, and that would be a millionth because a million has 6 zeros. 1,000, 3, 10,000, 100,000, and a million has 6 zeros. And if you have minus 7, you move not times 7 to the 10th, so you don't calculate 7 times 0 behind it, but 7 times 0 in front of it. And now you have 0.000001. The numeric 0.000001 is written as 1 times 10 minus 7 in scientific notation, which indicates that the number is 1 with the decimal point moved 7 places to the left. I'm going to explain it in a moment again. To convert this value to pH, this negative exponent minus C7 is changed to a positive number 7. A solution with a H plus, so the hydrogen ions, that is the acidity, concentration of 0.0001, that is 10 exponent minus 4, or to the minus 4, moles per liter has a pH of 4. A solution with a H plus concentration of 0.00000000, 10 to the minus 9 moles per liter has a pH of 9, and so on. So when we are talking about the balance of acids to bases, we're not talking about 50-50, we're talking about 0.0000.001 to 9999999. So we're talking like that. It makes a bit sense. So when we're saying something has the pH of 7, then it means that it has the amount of 0. And then 6 zeros and then 1. So 0.601 of what now? Moles per liter? Yeah, 1 million of a mole per liter. Okay, a mole is, I say it is 6,000 now. I don't know if it's 6.023 or 6,000. Okay, I say 1 mole is 6,000 to the 23rd or whatever amount of acid molecules inside of it. So it's the Avogadro number. We had it at the previous page. Avogadro number. It's 6,000 times 10 to the 23rd. So some number times it's like 6 quadrillion or something. Amount of molecules are in it. So we're saying if something has a pH factor of 2, it has 0.2 pH 2 to 0, so 0.001. It's always 1, just 2 zeros and 1 of 1 mole in it. And 1 mole are 6, I was going to say no billion, 6 quadrillion, whatever, 6 quadrillion molecules in it. So if something has a pH of 2, that means there are 0.001% of 6 quadrillion acid molecules in with 1 liter. Contains 1/10,000th of a mole of hydrogen ions per liter. Okay, so the other thing which I just mentioned a little bit, that scale is not, it does not go stronger, it goes exponentially stronger, because it's every time a 0 more. So pH 1, pH 2, pH 3 is always the 0 moved a complete thing 1/10 more. That means it gets very strongly stronger, I think now. I'm not completely sure about that. That means a pH of 0? I don't know. But I think we have it in basics. We're going to go on and I try to explain it again when I understand it better. The midpoint of a pH scale is 7. Okay, so we go on with the informations we get directly. Where the concentration of H plus and OH are equal. They're saying equal. Now I know why. The fluids, intercellular and extracellular, are not acids and bases. There is a big fluid, and that contains acids and bases. I understand it the way. Whereas, let's say water. There's a lot of water, and inside of this water is a drop of acids and a drop of bases. And if a thing has a pH of 7, that means there is now exactly as amount of acid as bases in that thing. That would make sense, but let's see. A substance with a pH of 7, such as distilled pure water, is considered to be neutral. A solution that has more H plus than OH minus is an acidic solution and has a pH below 7. Because it's the opposite way. The lower the 0 comes, so it's 7, it has the pH of 0, when the amount of 0 goes to 0, and therefore it has a whole amount of acid in it, a whole mole, therefore there's a lot of acid in it. we understand at least the basics of it. Let's read on. If we are able to understand these two things which I just said, which I now think are not true. A solution that has more OH minus than H plus is a basic or alkaline solution and has a pH above 7. It is important to understand that a change of one whole number on the pH scale represents a tenfold change from the previous concentration. A pH of 1 denotes 10 times more H plus than a pH of 2, whereas a pH of 3 indicates 10 times fewer H plus than a pH of 2 and 100 times fewer H plus than a pH of 1. Yes, so it's tenfold. It's not a little bit more, it's every time tenfold because you add a whole zero. Okay, we get the other thing. A 7 means it's neutral, the same amount of acids to bases. It would be great to know what pH mean. The proportion of hydrogen. I think we're just going to read on and find the answers to the things which I just said. That was the thing about how much water is there and how much the solution of what is what and so on. That it seems to be 7 means we're going to take the information we have. 7 means it is the same amount of acids as of alkaline, or as of bases. So of acids and of bases. If it goes lower than 7, it goes higher. So the number measures the acidity technically. So you can see it like that. If it has 7, it is neutral. If it has more than 7, like 8, then it is acidity. It levels the acidity, and 7 is the middle. The higher the number of the pH is, the more acid is in it. Because the more you have, the less zeros are behind it. No, it must be the other way around. What did we explain? A solution that has more H plus than OH is an acid solution. Okay. It has a solution below 7. It's the other way around. The lower the number, the higher the acidity. Okay, the lower the number, the higher the acidity. If you have 7, that is neutral. And now it makes more sense with the zeros. If you have a low number, like pH 2, you have just 2 numbers. Now you have 0.001, but it's already pretty aciditous. If you have pH 3, you have 3 zeros there, so it goes less aciditous. If you have pH 14, you have 14 zeros after the decimal, so it's very little acidity. Okay, it makes all sense. It was the biochemistry part. In short, the more 7 is neutral, and if it goes lower, it means there are less zeros behind the dot. And that makes it higher in concentration. It is higher if it's just 2 zeros, 0.001, when there are 5, 0.001% of a mole. And that is the amount of a mole in it. And the mole are 6 quadrillion, whatever, of this molecule acid in it. So this pH 4, there are 0.00001 of 6 quadrillion acids in the solution. And if the pH goes lower, there are less zeros, and therefore there's a less percent. The 0 comes closer to the 1 to be a full one, and then it would be more of acid. That was the biochemistry part. If you were here for biochemistry, you can go directly to the next part of biochemistry, where we will read the whole thing again and try to understand it better. If you stay here and participate in the shortened extensor carbonary strength training, then is that at your own risk. Good instead of stand, arms next to us, hands on to fists, bring the fists down with fists. Hanging up. We're having 3 rules. The first rule is that we are stopping immediately as soon as there's pain. The second rule is that we're going only as far as we can go with a little bit of effort, and our fists are quite enough. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. And we just have 50 seconds left. So we're going to take that out. So just make strong fists and turn them to the outside. Only as far as it goes, and to the inside. And now bring the wrist down. And straight fists, and now again down. Press equally all fingers together. And again up. And now just press the neutral position. That was for short and extensor carbonyl strength. We don't have time if we did too much biochemistry. Anyway, I thank you very much, and until next time.